This is where we left off in 1.11, and we're going to continue for g of x. But again, we're going to be flipping back and forth to this page that has g of x. Maybe I should highlight that we're looking at this function now to begin this video. So anyway, we're going to examine at x equals -3 now, because that's where the left function stops and the right function begins. And at x equals -3, if you look at the graph, I think it's very evident that there's a jump from this piece to this piece. It's like a magic that you go from here and then skip all the way down to describe this jump discontinuity. So definitely a jump. I forgot to mention earlier, in the previous video, at what x value it's at x equals -3 in this problem, which kind of explains why we look at where the function stops to the left of -3 and it begins to the right of -3. Now, what's new about g of x now is that it is defined. One of these functions or conditional statements is true because it equals at -3. So that's going to tell you to go to the top equation and plug in -3 in for that x. So is it defined? Yes. And then you can use that equation, the negative of -3, I already forgot what the value was, plus 6 squared plus 7. There's a lot of moving here. Sorry if I make you dizzy. So as you look at that, you can clearly see that it's 3 squared is 9, the negative of 9 plus 7 is -2. So this is the actual value of that, and you can clearly see it by the graph. All right. So as we look at the next piece, if you look at the graph, the left side of -3, well, we just looked at it and we agreed it was -2, but I'm going to go back to look at the right side. So on the left side, that is this graph, we're looking at the y value is -2. Now let's look on the right side. So the right side of the graph, yes, it's a hole here. It's undefined, but we can say it's for sure getting closer and closer to the y value of -4. Now we can verify that by doing the next part, which is using the equations. Now, as we do the x approaches -3 on the left side, that's actually the same work that we did up here. G of x is going to go closer and closer to negative of -3 plus 6 squared plus 7, which equals -2. I gave the hint to one class, or maybe both classes, that every time we write a piecewise function, we do go in order. So the top equation is always the furthest to the left, and if there's a middle equation, that would be in the middle, and then the bottom equation would be furthest to the right. So whenever you're doing the left side, every math book I've seen and every problem I've written, unless I mess it up when I write the problem, because that does happen, the top equation will be the left side of whatever we're examining. And then the right side is going to be the bottom equation. And I hope that's helpful. So as we look at, as x approaches -3 from the right, then we can say g of x, we can plug in -3 in to the bottom equation, the negative of the square root of -3 plus 3, and then I believe it's -4. There's a lot of going back and forth. There we go. So as you look at this, I hope you can do this in your head, by the way, because -3 plus 3 is 0, the square root is 0, 0, -0 minus 4 is -4. But as I was trying to point out to you in the earlier video, is there's basically 1, 2, that doesn't show up. You're looking at these 3 values. And if all 3 of the values are the same, then it's continuous. Well, clearly these 2 are not the same, so it might be beneficial to just look at these well, you still want to look at all three of them. But if these two are different, then it is a jump discontinuity. So I think I labeled them 1, 2, 3. I don't always do this, that's why. But since -2 does not equal -4, this is a jump discontinuity. I like to be more specific. G of x has a jump discontinuity at x equals -3. So let's look at some holes or point discontinuity, which is definitely happening in H and P for that. Doesn't matter. I'm fine if you write holes or if you write point. Just know multiple choice questions. Sometimes they have multiple answers. So there's a hole point discontinuity here at H of x, and we're examining at x equals -1, because that's where the graph stops and starts. So point discontinuity at x equals -1. And there's a difference between the left side and the right side. Now if you go back, it is not defined. It is undefined at x equals -1, because as you look at your piecewise function, there's no equal to say, oh, I'm going to use the top equation or I'm going to use the bottom equation. So it is not defined there. So now you need to just do the left-hand behavior. Let's look at the graph first. So on the left side, we're getting closer and closer to the y value of 1. And on the right side, we're getting closer and closer to a y value of 1. So they both equal 1, positive 1, on the left and the right side. Well, now we can actually do the arithmetic as x approaches -1 on the left side. H of x is going to get closer and closer to. And I hope you're following my advice that the top equation is always going to be the left side as long as they write the problem correctly. And you're going to plug in -1 in for that equation. So the absolute value of -1 plus 4, what was it, -2? I should have planned better and had everything set up. But anyway, as you plug that in, you get 3 minus 2 equals 1. I didn't do this on the previous one, but you can see, this value matches this value because I'm doing the same arithmetic. So as I go and do as x approaches -1 on the right side, so the positive superscript, we're going to go to the bottom equation and plug in -1 in for x. So negative of -1 minus 1 squared plus 5. Let's see if I can remember that. The negative of -1 minus 1 squared plus 5. Well, let's look at that. Well, negative of -1 is -2 squared is positive 4. -4 plus 5 equals 1. I'm going to get a different color highlighter out. You can see how that matches because this needs to match. But how do we know this is a point discontinuity now? That's the whole point of me walking you through this, is as you examine the three pieces, let's use red, this number, and this number. Remember I gave it away earlier that if this number equaled this number and equaled this number, then it's continuous. Well, there's not even a number up here for that to be true. It's not defined at x equals -1, so it can't be continuous. So now you can look at these two numbers, and if they're different, then it's a jump. Well, they're the same. So there's my quick answer for you. Since 1 is equal to 1, and it's undefined right there, h of x has a point discontinuity. Now, you have to be careful with this answer because if there is a 1 up here, so it is defined and the h of -1 equaled 1, then this would be a continuous function. So maybe I should put that in here. And h of -1 is undefined. So this value does not equal these two at x equals -1. All right. Sometimes I try to go too fast, and then I forget to mention something important. So that's why we try to have class time still, so you can ask those questions. Here's another one, P of x, where we're examining x equals -3. I already told you that this is a point discontinuity, even though it's defined down here. I'll explain why here shortly. Okay, so we're looking at x equals -3. That's all I was trying to get at. So we're looking at, for P of x, is a point or a whole discontinuity at x equals -3. And so that's going to be your left piece and your right piece, and they kind of already gave it to you right there. But now, this time it is defined, and P of -3 is equal to a value, and if you go back to the function, it's saying, okay, well, when x is -3, the y value is -2. And while I'm looking at it, let's go ahead and answer the left and right side if we're looking at the graph. Please let me know, email or in person, if the left side's getting closer to a y value of 2, the right side's getting a y value of 2 as well. Oops, too far. So I think this was -2, the left side was +2, the right side is 2. So as x goes to -3 from the left side, P of x, we're going to use the top equation. The top equation is 1/3 times -3 plus 3. And you plug in -3 right there. -1 plus 3 is 2. -3 from the right side. Now go to the bottom equation and plug in -3 in for that value, that expression. So -3 is going to the bottom equation because this is the right side of -3. -3 minus 1 is -4. Absolute value makes it +4. Minus 2 is 2. If you need to write out all those steps, I would strongly encourage you to do so. So as I mentioned before, you're looking at this number, and this number, and if they're all the same, then it's continuous. Are they all the same? No, so it's not continuous. So then look at these two values. If these two values are the same, since -2 does not equal the 2, but the 1, 2 equals the other 2, P of x has a point discontinuity, or a whole, at x equals -3. So I'm going to stop the video here. I knew this was going to be a long one. And soak it in, pause, rewatch it, and then we can finish the notes.